Good day everyone. Today I'll be explaining the connection between the Zeroth Law of Thermodynamics, temperature, thermal equilibrium, and temperature scales. Zeroth Law of Thermodynamics. The Zeroth Law of Thermodynamics was first formulated by Ralph H. Fowler in 1931. Its main concern is thermal equilibrium, which occurs when two bodies have the same temperature and no heat flows between them. The law states that if object A is in thermal equilibrium with object B and object A is also in equilibrium with object C, then object B must also be in equilibrium with object C. This concept is very similar to the transitive property in algebra. The zeroth law is important because it provides a foundation for defining temperature and makes the use of thermometers possible. The zeroth law of thermodynamics explains the concept of thermal equilibrium, which means no heat flows when two objects have the same temperature. In simple terms, if two objects are equally hot or cold, there is no heat transfer between them. For example, if object A is in thermal equilibrium with object B and A is also in equilibrium with object C, then B and C must also be in equilibrium. This law is very important because it serves as the basis for measuring temperature and explain why thermometers work. A thermometer functions by reaching thermal equilibrium with the object being measured, which allow it to show the correct temperature. Temperature is a measure of how hot or cold an object is. On the molecular level, it is defined as the measure of the average kinetic energy of the molecules that make up an object. Temperature determines the direction of heat flows, always moving from a hotter body to a colder one. To measure temperature, instruments such as thermometers are used and different numerical scales like Celsius, Fahrenheit, Kelvin, and Rankine have been developed to quantify it. Temperature measures how hot or cold an object is. On a molecular level, it represents the average kinetic energy of the molecules. The faster they move, the hotter the object becomes. The slower they move, the colder it is. Heat always flows from a hotter object to a colder one until both reach the same temperature. There are also different temperature scales used to measure heat: Celsius, Fahrenheit, Kelvin, and Rankine.
Thermal equilibrium. Thermal equilibrium happens when two objects are touching or in contact have the same temperature. When a hot object touches a cold object, heat flows from the hotter one to the colder one. This continues until both objects reach the same temperature that when thermal equilibrium is reduced. At that point, no more heat flows between them because they are already equal in temperature. For example, if you put a hot metal spoon into a cup of cold water, the spoon will cool down and the water will warm up. After some time, uh, they'll both be at the same temperature. So that's the thermal equilibrium. Temperature scale. There are several temperature scales: Celsius, Fahrenheit, Kelvin, and Rankine. So there's a formula of Celsius and Fahrenheit. So the formula of Fahrenheit is temperature in Fahrenheit is equal to 9 over 5 multiplied by the Celsius plus 32. And the formula of Celsius is temperature in Celsius is equal to 5 over 9 multiplied by the temperature in Fahrenheit minus 32. So if our given is Celsius, then the formula that we use is temperature in Celsius is equal to 5 over 9 multiplied by the temperature in Fahrenheit minus 32. Then next is, if our given is Fahrenheit, the formula that we use is temperature in Fahrenheit is equal to 9 over 5 multiplied by the Celsius plus 32.
If it's 68 degrees Fahrenheit, what is it in Celsius? So our given is Fahrenheit. Then the formula that we will use is temperature in Celsius is equal to 5 over 9 multiplied by the temperature in Fahrenheit minus 32. So, gigamit nato nga formula is temperature in Celsius is equal 5 over 9 multiplied by 68. So, 68 is given. Minus 32 is equal 5 over 9. Then, divide ang 5 over 9 is equal 0.55, then round off 0.56 times 36 is equal 20 or 20.16 degrees Celsius. Next, if it's 25 degrees Celsius, what is it in Fahrenheit? So what we're given is Celsius, then the formula that we will use is temperature in Fahrenheit is equal to 9 over 5 multiplied by the temperature in Celsius plus 32. So mo niya to ang gigamit karon. So 25 is given, then temperature in Fahrenheit is equal 9 over 5 that multiplied by 25 given na plus 32. Then gi-divide na to ang 9 over 5 is equal 1.8 times 25 is equal to 45 plus 32. Then the final answer is 77 degrees Fahrenheit.
Temperature at which all molecules stop moving is known as absolute zero, and this forms the basis for the Kelvin scale. Its 0 point corresponds to negative 273 degrees Celsius. For Kelvin scale, temperature are not measured in degrees but in Kelvin. The freezing point of water is at 273.16 Kelvin, and the boiling point of water is 373.15 Kelvin. Indeed, any temperature on the Celsius scales can be converted to Kelvin by adding 273.16 Kelvin to it. The formula for Kelvin is T sub K equals T sub C plus 273.16 Kelvin. The Kelvin scale is used to measure very low temperature, and it starts at what we call absolute zero, the point where all molecules stop moving. At absolute zero, the temperature is 0 Kelvin, which is the same as negative 273 degrees Celsius. So if we want to convert Celsius to Kelvin, we just add 273.16 Kelvin to the Celsius temperature. Example, a scientist recorded the temperature of a chemical reaction as 30 degrees Celsius. Convert this temperature to Kelvin. The given is T sub C equals 30 degrees Celsius. The formula is T sub K equals T sub C plus 273.16 Kelvin. The solution is T sub K equals 30 plus 273.16 Kelvin equals 303.16 Kelvin. Therefore, the temperature of the chemical reaction is 303.16 Kelvin. The Rankine scale is the Fahrenheit counterpart of Kelvin scale. The Fahrenheit scale and Rankine scale are related. The formula for Rankine scale is T sub R equals T sub F plus 460. The Rankine scale works the same way as the Kelvin scale, but it's used with the Fahrenheit system instead of Celsius. In this scale, 0 degree Rankine is also absolute zero, just like 0 Kelvin. To convert Fahrenheit to Rankine, we add 460 to the Fahrenheit temperature. Example, an engineer recorded the temperature of a gas sample as 75 degree Fahrenheit. Convert this temperature to Rankine. The given is T sub F equals 75 degree Fahrenheit. The formula is T sub R equals T sub F plus 460. The solution is T sub R equals 75 plus 460 equals 535 degree Rankine. Therefore, the temperature of the gas sample is 535 degree Rankine.